All right. So yesterday we talked about all the vocabulary with transformations. So remember, you have to know what pre-image is, an image, isometry, rigid motion, and then the notation that's associated with that stuff too. And then we talk more specifically about translations. Remember, the whole deal with translations is you just add or subtract from the x and y coordinates, depending on which direction you're moving. So any questions on that stuff? Okay, so then today we're going to talk about the next type of transformation, which is reflections. Okay, so a reflection is just, well, there's two different types of reflections. First of all, there's line reflections and point reflections. So let's talk about line reflections first. Line reflection is like a mirror image. Okay, so I mean, I did it, and I showed you an example of this like yesterday, but if I have like, for example, capital letter B, like this, right? And I reflect that over this line L, which is called the line of reflection. Obviously, its image would look like a B, like this, right? Okay, so this is an example of a line reflection. Okay, L is called the line of reflection. All of the other vocabulary still applies. So this capital letter B would be the pre-image, and this would be the image. Okay. So when you're talking about coordinate geometry, like points on the XY axis, there's several common types of line reflections that you're expected to be able to do. Before we start this, if you don't have a piece of graph paper, you should grab a piece of graph paper, because that's really the best way to do this, is on graph paper. Okay?
Is it every 22nd?
Yeah, it is, 22nd. So I'll just write that. The best way to find image of a line reflection is to graph it. I wouldn't have necessarily said that about translations. You can find the image under a translation by graphing it, but I think it's almost easier to do it just by adding or subtracting from the coordinates, right? It's just an easier process. But with line reflections, there are formulas, like you could memorize, like, what do you do if you reflect over the x-axis? Well, you're really just negating the y value or whatever, like you could remember, like, for every possible line reflection, what the rule is for that line reflection in order to get the image. But it would be a lot of stuff to memorize, and it's really not worth it. It's really easy to get the image just by graphing the point and the line of reflection. So I think that's just the best way to do it here. Okay? So there are several common line reflections. Including over x-axis, over the y-axis, over any vertical line, where the equation of a vertical line, remember, is x equals some number. Over any horizontal line. Those are equations that look like y equals some number. Over any line of slope plus or minus 1. So this would be an equation that looks like y equals plus or minus x plus b. I don't know if that's confusing or not, but think about mx plus b. M is either positive 1 or negative 1. So this is just like plus or minus x, and then this b could be any number. Okay, so those are the common line reflections that you're likely to see. The notation, the symbolic notation for a line reflection, symbolic notation, is lowercase r, the subscript. So the lowercase r, and then the subscript is, I'm just going to say L, the script L. That's a subscript. And this is just whatever the line of reflection is. So for example, if they asked us to find the reflection across the x-axis of the point -5, 2. Okay, I'm gonna get a piece of graph paper here. Okay, so all I'm going to do is I'm just going to plot the point and plot the line that I'm graphing over, or that I'm reflecting over, and then just find the image that way. So if I start with -5, 2, that's here, right? The x-axis obviously is the x-axis, but I'll just go over it with a dotted line, just so that you can remember what we're reflecting over. So there's the line that we're reflecting over. So all you're going to do in any line reflection is you're going to go directly to the line of reflection perpendicularly, and then across it the same number of units. That's it. So like in this example, if it takes 2 squares to get to the line of reflection, then you're just going to go 2 squares on the other side of the line of reflection. Okay, so the image would be right there. And the coordinates at that point are -5, -2. That's it, that's the image. That would be the answer. If they said find the image of the reflection over the x-axis of the point -5, 2, the answer would be -5, -2. So like I said, there's a formula there. I mean, that's always going to be the case. If you're reflecting across the x-axis, you're always just going to take the y value and make it negative. That will always work. That formula will always work. But I urge you, don't try and remember these formulas, because look at all the different lines of reflections there are. There's a bunch of them, right? This is a single line. This is a single line. This is tons of lines. This is also tons of lines. This is tons of lines. So like you can't remember a formula for every possible scenario. It's just not practical. So don't try and do that, okay? You get no extra credit for not graphing it, okay? Nobody's gonna think you're smarter. Quite the opposite. I think it's foolish to not graph these, because they're so easy to do by graphing. What if they said something like, reflect across x equals 2, the point 3, 0. Okay, same thing. I'm going to plot the pre-image point, the point that I'm starting with, 3, 0. That's here. This time, the line of reflection is x equals 2. What type of line is that? It's vertical. Wait, what did you say?
This is saying that it's the x-axis?
No. The x-axis has an equation y equals 0. All right? Let's just review. Okay, so I glossed over this. Maybe I thought it was, you guys remember this from last year. A vertical line, any vertical line has an equation x equals some number. So x equals 5 would be the vertical line passing through 5. X equals -6 would be the vertical line passing through -6. X equals 0 would be the y-axis, okay? Any horizontal line has an equation y equals some number. So the x-axis actually has an equation y equals 0. They could have written that here and it would be the exact same line reflection. Y equals 10 would be way up here. Y equals -4 would be down here, right? So that's vertical and horizontal lines. It's x equals something if it's vertical, and it's y equals something if it's horizontal, right? So this is actually a vertical line passing through the x-axis at 2. Okay, so I'm going to graph that as a dotted line again. Here. And then it's the same deal. I'm just going to go straight to the line of reflection, count how many numbers of squares I went. It was only one unit, right? One square away. So then you just go across that the same number of units. The image would be right there. Here to there. So this image would be 1, 0. Do one more on this set of axes, then I'll switch so the graph doesn't get too cluttered. What if it was reflection across the line y equals x, and the initial point was 7, 4. So I'm going to start with 7, 4. Over 7 up 4. And I'm reflecting across y equals x. What does that line look like?
A vertical line?
It's not. Vertical lines have an equation x equals some number.
Oh, horizontal.
Horizontal lines have an equation y equals some number. What if it's y equals x? It's through the middle point, yeah, but what does it look like? What is it sloped or? Y equals mx plus b, so that's that form. What's the slope of that line?
0.
No? 1, and what's b?
0.
0. So this is a line of slope 1, y-intercept 0. It's like the main diagonal that passes through the origin. You guys did this last year, 100% sure, right? You guys spent a lot of time graphing lines. Yes? So you need to remember. Okay, so this is y equals mx plus b. M is 1, b is 0. So this is a main diagonal line of the graph. So it looks like this. Has a slope of 1. Y-intercept is 0, so it looks like that. That's the line that I need to reflect over. So it's the same principle. I'm going to go straight to the line perpendicularly. Well, if I go perpendicularly, it's going to be like of a slope -1, right? If this slope is positive 1, then a perpendicular line would have to have slope -1. So I'm going to go straight to the line with a slope of -1. And that took me 1.5 diagonal squares, right? I went through one square and then half of another one. So then I just have to go across it 1.5 diagonal squares, like that. And the image point would end up being right there. Does that make sense? I mean, definitely, that's the reflection of that point across that diagonal line. So the image ends up being 4, 7. Okay, let's do some more examples, but on a different piece of graph paper. What if we have the point, or a reflection across the line, y equals -x plus 2. And the pre-image point is the point 0, -3. So I got some graph paper. Here, I'm going to graph the point 0, -3. Right here. Now I need to graph the line y equals -x plus 2. What's the slope of that line?
-1.
-1. What's the y-intercept? 2. Good job. So I need to graph that line. Again, I'm going to graph it as a dotted line. So it's slope of -1, y-intercept of 2, it looks like that. And start counting squares. I'm going to go directly to the line. In this case, it's 2.5 diagonals, right? Oh, I didn't mean to write that as a dotted line. So in this case, it's like 2.5 diagonals to get to the line of reflection, right? Then I just go across it, 2.5, the same direction. The image would be right there. So this would be 5, 2. Is this making sense? Sometimes it's hard to tell if it's a diagonal line if you have the right point. Here's a common mistake. What people will do is they'll say, oh, from here, I'm just going to go straight to the line, and they'll go vertically to the line. They'll say, oh, that's 5 squares, and I just go up 5 squares from there. There's the image. But if you turn your head diagonally so that the line of reflection is straight up and down, it becomes really obvious that that answer is not correct. But that's a common mistake that people make, okay? So try not to make that mistake, okay? You want to go perpendicularly to the line that you're reflecting over, not vertically or horizontally necessarily. If the line is diagonal, definitely not, right? All right, what if it was something like reflection across the line, x equals 0. And the initial point is -3, 9. So -3, 9 is here. What does the line x equals 0 look like? Vertical line passing through the x-axis at 0. So it's really the y-axis, right? X equals 0 is the y-axis. So graph that, y-axis, the dotted line. That off here. Okay. And then I'm going to go straight to the line of reflection, the y-axis, and then across it the same number of squares. So this is 3. I'm going to go across it 3 more, and I end up right there. So this answer would be 3, 9. do one more example, and then we'll move on to point reflections. How about a reflection across the line? Y equals x minus 1. And suppose you're starting at the point negative 5, 2. So I have negative 5, 2. That's here. The line y equals x minus 1 look like? What's the slope? 1. Y-intercept? Negative 1. All right, good. So I'm going to plot that as a dotted line. So it's going to be, I'll get rid of that. What do I do? Well, I know it's going to be 1 down. Let's make a guess. Maybe it's this one. It was right. So it looks like that. Right? Passes through the y-axis at negative 1, has a slope of positive 1. So I'm going to go straight to the line of reflection perpendicularly and count squares. So this is 1, 2, 3, 4 diagonals. Go across it. 1, 2, 3, 4 diagonals. There's the image. So this point ends up being at 3, negative 6. That makes sense? It seems to me that the hard part here is going to be remembering what you learned last year, which is graphing the lines. So don't forget, make yourself good notes where you tell yourself really clearly if it's x equals a number, it's a vertical line. If it's y equals a number, it's a horizontal line. And if it's y equals mx plus b, if there's x's and y's, then you just figure out the slope and the y-intercept. So remind yourself of that so that that's not an issue. Okay, so that's line reflections. The second thing that you have to do then is a point reflection. So a point reflection is kind of like a line reflection, except that you're just reflecting through a point, but it works the same way. So point reflection, I don't really know what to say about it, so I'll just draw an example, and then we'll do some graphical. So a point reflection would be, suppose you have a figure, like a triangle, like this, okay? And suppose you wanted to reflect this triangle through a point. Now let me just give this some vertices, A, B, C, so we know what point goes where. And let's say that the point of reflection is right here, point P. So it works the same as a line reflection works. You're going to take each point separately and reflect it through the point. So like, for example, point B is going to go directly to the line of reflection, or the point of reflection rather, and then through it the same number of units. So its image would be like here. This would be B prime. This distance right here is the same as this distance right there. And you do this for all 3 points. So like point C is going to start here. It's going to go directly to point P. And then across it, the same number of units. So it's going to end up being here. This is going to be C prime. This distance is the same as this distance. And then same thing goes for A. A is going to start here. It's going to go directly to P, and then across it the same number of units. So it's going to end up being here, A prime. So you end up with a triangle that's like almost like a rotation of the original figure. And that's always how it's going to turn out. A point reflection actually looks like a 180-degree rotation. Point reflection looks like a 180-degree rotation. But all we're going to be doing right now is reflecting a point through a point. So it's just going to look like going through a point, a single point. So it's not going to be, it's not going to look like a rotation when you just have one point. Obviously, it just looks like it's moving, but it's actually kind of like a rotation. So if I had, for example, a reflection across the point -2, 1, the point 5, 6. Again, I strongly recommend that you use graph paper because I really don't know how you do this any other way. Okay? So what they're saying is start at 5, 6. That's here. And reflect across the point -2, 1. So -2, 1 is here. The best way to do this is to use slopes, right? So like, if this is the point of reflection, this is the point I'm starting with, A. This is the point of reflection, P. Basically, I'm going to go from here to there. So from there to there, I'm really going down 5 and over 7. So to get to the image point, I'm just going to go down 5 and over 7 again. Right down, right? 1, 2, 4, 5, 6, 7, yeah. Great. Yeah. So the image would end up being right there, A prime. But what I really actually did is I went straight to the point P and then across it the same number of units. It's just harder to count those units if it's not either a line of slope -1 or +1, where you could just actually count diagonals of squares. Or if it's a vertical or horizontal line, then it's easy to count squares. But if it's just a randomly sloped line, like with a slope of 7 or 5/7, it's hard to count squares without actually doing slopes. You know what I mean? So that's the easiest way to do it. But you can see it's really this is really the same thing I did up here. I'm going straight to the point that you're reflecting through and then across it the same number of units. Straight to the point you're reflecting through and then across it the same number of units. Let's do one more example. How about, so anyway, the image would be -9, -4. Let's do one more example. Suppose it was reflect across the point 5, -4, the point 20. Trying to do it in an area where I haven't used graph paper. So if I have the point 20 that I'm starting with, let's call that B. And I'm reflecting across the point 5, -4. -4 is here. Let's call that point Q or something. It's the same thing. I want to go straight to that point and then across it the same number of units. But in order to get the exact, right location, I'm going to use slopes. To get from here to here, I'm really just going down and over. I'm going down 4 and over 3. So I just want to go down 4 and over 3 again. You can see the image ends up being right there. This is B prime. So the answer would be 8, -8. questions? So there's two types of problems on the homework. There's reflections over lines, and they're either going to be vertical lines or horizontal lines, or lines of slope 1 or lines of slope -1. It's difficult to reflect a point over a line that doesn't have a slope of 1 or -1, but it's sloped. It's hard to figure out like the perpendicularity and getting the right number of units across, unless it's like a really rigged problem that just happens to turn out perfectly. So they're not going to give you problems like that where the slope isn't 1 or -1 or vertical or horizontal line, okay? And then there'll be point reflection problems on there too, okay? So the homework's on Delta Math. It's just called reflections, and that's it.